Welcome to this quantitative problem set on geometric optics. This video will cover 3 problems with step-by-step solutions, focusing on 3 learning outcomes. Problem 1 asks for the power and units of a lens with a focal length of 0.50 meters. We will use the relationship between power and focal length, where power is measured in diopters. The relevant formula is P equals 1 over F. Substituting the focal length, P equals 1 divided by 0.50 meters, resulting in 2.0. The unit for lens power is the diopter, so the final answer is 2.0 D. A positive power indicates a converging lens. Problem 2 is a magnification calculation. An object has an image distance of 1.50 meters and an object distance of 0.75 meters. We need to find the lateral magnification and its units, which is a unitless quantity. The formula for lateral magnification is m equals minus d sub I over d sub o. Substituting the values, m equals minus 1.50 meters over 0.75 meters, giving m equals minus 2.0. Since magnification is a ratio of 2 distances, the units cancel out, making it unitless. The negative sign indicates an inverted image. Problem 3 applies the thin lens equation. A light bulb is 0.75 meters from a converging lens, forming a real inverted image 1.50 meters away. We will calculate the focal length using the formula 1 over d sub o plus 1 over d sub I equals 1 over f. We substitute the distances into the thin lens equation. 1 over 0.75 plus 1 over 1.50 equals 1 over f. After finding a common denominator and adding the terms, we get 3 over 1.50 equals 1 over f. Inverting both sides yields a focal length f of 0.50 meters. This positive focal length confirms a converging lens.